A machine produces rubber fan belts with a braking tension normally distributed with a mean of 64 newtons and a standard deviation of 5.32. On a certain day, a sample of 60 was tested and found to have a braking tension of 62.6 newtons. A hypothesis test at the 5% level, is conducted to determine whether there has been a change in the mean. The manager uses statistical software and obtains the following results. Using these results, write down the null hypothesis and the alternate hypothesis and state both the type of test and the conclusion, given a reason for your answer. All right, the hypothesis test, 5%, is looking for a change in the mean. We're not looking for a definite increase or decrease. Therefore, this is a two-tailed test. 80 mu is equal to 64. Okay, there's no change in the mean braking tension, and the alternate hypothesis is mu is not equal to 64. You need to be very careful how you write these down, please, in an exam. There is a change in the braking mean. B, two-tailed test. Okay, there is a big clue here as well. It's performed as we're looking for a change in the mean. Okay, so under 80, what would be the rejection criteria? Okay, to find the rejection criteria for two-tailed tests at the 5% level, if you had to calculate it manually, so if you go to your calculator, okay, let's exit this. Okay, and if we go to F5 distribution, F1 normal, inverse, which is F3, Okay, we'll look for the left-hand side, but the area would have to be 0.025. Okay, the standard deviation would have to be 1 if we're using the standard normal curve, and the mean 0, and that would give you minus 1.96, which you should be sort of familiar with anyhow. Okay, so Z would have to be equal to, this has been given to us on here, the Z value is minus 2.02384, and we'll look at how to calculate the p-value in a minute. The p-value would be that times 2. So let's look how to calculate the p-value. All right, so we need to take into account from the table that the standard deviation is 5.32, and this would have to use the square root of 60, because there are 60 in n. Okay, and we have to use a mean of population mean of 64, and we'd have to look at the sample mean, which is 62.6. and where that would lie at one end, and obviously that's less. We'll look at the negative end of the distribution. So if we go to our calculator now, it's probably better if we do this in mode 1. Okay, so let's just delete everything that we've got here already. Okay, so option, stat, distribution, normal, okay, NCD, okay, so the parameter, the lower value will be minus 1,000, so we just need a very negative low value, so comma, okay, 62 is the upper bound, 0.6, comma, the standard deviation here would be 5.32 over the square root of 60. Okay, comma, and we'd have to put in the mean, which is 64, enter. All right, and then we have to multiply that by 2 because it's a two-tailed test, and that gives me the p-value. So you can see that's less than 0.05, therefore we're going to reject 80. Okay, so if you draw a graph, always drawing a graph is helpful. Okay, so minus 1.96, 1.96. Each of these is 0.025. Together make up 5%. We reject 80. Okay, my value of Z, you can see from here, will be over here. We reject, or the p-value is less than what we want, so therefore we can reject. That makes the diagrams a bit more meaningless for the p-value. So the conclusion would be, as Z is less than minus 1.6 or the p-value is less than 0.05, we reject 80 and say there is significant evidence at the 5% level that there has been a change in the mean. Okay, make sure you don't use the word prove. Now, it is possible to do the whole of the test on the calculator. So let's just quickly go over that as well. Okay, so going to the calculator. Now to do this, you need to go to the statistics mode. So we need to go to number 2. Okay, you need to press F3 for test. It's a Z test, and it's one sample. That's all you're ever going to do at A level. It is a two-tailed test, so we want F1. The population mean is 64. Okay. The standard deviation is 5.32. Enter. Okay, the mean is 62.6. Enter, and there were 60 in the sample. Okay, if you enter. Okay, so you get the Z value that we calculated, the P value. Okay, so again, you would just reject 80. Okay, so this has been a video to show you how to do a two-tailed test. We've been using the calculator, so I'm sorry for these videos being slightly long. I hope you've understood, and I thank you very much for watching.